Hello everyone, my name is Murutula Enoch and we are going to revise together logarithm and exponential. So the first question reads, solve the equation log base 3 of x minus 4 log base x over 3 plus 3 is equals to 0. So we can start answering. So we have log base 3 of x minus 4 log x over 3 plus 3 is equals to 0. So under these kind of questions you have to be very careful. So you have to think critical. So if you look at the bases that you're having there, they are different. So what are you going to do? You have to change the what? The base. So we are going to handle this one. Now there are certain properties that you should abide to. So you should know this one to say when you are having log of a log base a of b, this one if you want to change it, it's more like you introduce 1 over. If this b wants to become the base, what's going to happen is that they are going to swap once you just introduce that one. So they are going to be log b of a. So that is what I'm going to do there. So I'm having log base 3 of x minus 4 open brackets 1 over log. So here I'm changing the base. Why? Because I've introduced the 1 over. So it is going to be base 3 over x close the brackets plus 3 is equals to 0. Now since you're having the logs having the same bases, what you're going to do is that is to let. So you say let log 3 of x is equals to any letter of your choice. In this case I'll put k. So that simply means that where there is log 3 I'm going to replace it with what? With k. So that is k minus 4 1 over k open the brackets plus 3 is equals to 0. So there I'm having k minus 4 times 1, that is 4 over k plus 3 is equals to 0. So what I'm going to do is that to kill this denominator k, I'm going to multiply the entire equation by what? By k. So k times k, that is k square. So this k and that k, they're going to cancel each other. I'm going to remain with the 4 plus 3 times k, that is 3k is equals to 0. So from there you can see that now it has become a quadratic equation. So what I'm supposed to do is that I have to find the product sum and factor. So let me just rearrange it. That is k square plus 3k minus 4 is equals to 0. So product. So to get product, what you're supposed to do is that you have to multiply the coefficient of k square with the constant number. So that is 1 times negative 4, that is negative 4. And then sum, that is positive 3. And then factor. So factors, there are numbers that when you multiply you get the product, and then when you add you get positive 3. So that is 4 and negative 1. So when I multiply 4 times negative 1, that is negative 4. When I add these two, I'm going to get positive 3. So that is k square plus 4k minus k minus 4 is equals to 0. So from there, what I'm going to do is that I have to factorize what is common. So what is common between here, that is k. So k, I'm going to remain with k there plus what? 4. So what is common there, that is negative 1, open brackets, that negative 1 into negative k, that is positive k. There I'm having positive 4 is equals to 0. So what I'm going to do is that I'm going to couple that k with negative 1. So it's k minus 1. That is k plus 4 is equals to 0. So either k minus 1 is equals to 0 or k plus 4 is equals to 0. So k is equals to, so when this number crosses the equal sign to become positive 1, and then when that one crosses the equal sign to become what? Negative 4. Now we have to recall, you have to recall what you did there. At first you related to say let log 3 log base 3 of x is equals to k. So say recall. So log base 3 of x is equals to what? K. So that simply means that since you have calculated the values for k, you're going to replace. So I'm going to start with 1. So log 3 of x is equals to 1. So the rule is that this base is going to shift that number to become a power. So I'm going to remain with x. So x is equals to 3 to power 1. So x is equals to 3. And then, so this is one of the value of the what? Of the answer. This is one of our answer. So I should also go to that negative what? Negative 4. So log base 3 of x is equals to negative 4. So the rule is that this base is going to shift that number to become a power. So you're going to remain with x is equals to 3 to power negative 4. That simply means that to kill this negative, you have to introduce 1 over 3 to power 4. And this is according to the rules of indices. So that is x is equals to 1 over 81. So these two, so x is equals to 3 and x is equals to 1 over 81. These are the possible solutions that were supposed to be on question 1. So we can proceed to the second one. So the second one, they are saying solve for the real values of x given the equation 2e of x minus 3e to the power negative x plus 5. So we can also solve that one. So that is number 2. So we are having 2e of x minus 3e negative x plus 5 is equals to 0. So what you are going to do is that you have to be very careful. First, you simplify the entire equation that you have been given. Let me rewrite. That is 2e to power x minus 3. So I'm going to change this part alone. So that simply means that since there is a negative, what I'm going to do is more like I'm going to introduce 1 over e of x. So the way I've written there, the same as writing like that. So plus 5 is equals to 0. So what you are going to do is this, and you are going to multiply the entire equation by e to the power x, so that you change it to be a quadratic. So when I multiply that e to that, I'm going to have 2e x square minus, so that one and that one, they are going to cancel. That is, I'm going to remain with the negative 3 plus 5, and that is equals to 0. So what I'm going to do there is that I'm going to say let e to the power x is equals to any letter of your choice. In this case, I'm going to use k. So that is k, so meaning where there is e to the power x, I'm going to replace it with what? K. That is 2k square minus 3 plus 5k is equals to 0. So that is 2k plus 5k minus 3 is equals to 0. So this is now a quadratic. So what I'm going to do, the same procedure. So to get the product, you have to multiply the coefficient of kx square with the constant number. So that is 2 times negative 3, which is negative 6. And then the sum, that is positive 5. Factors, numbers that when you multiply, you are getting the product. And then when you add, you are getting the sum. So what are those numbers? That is 6, also with negative 1. So I'm going to replace on the equation, that is 2k square plus 6k minus k minus 3 is equals to 0. From there, I have to factorize. So what is common between that and that? So the thing that is common is 2 and k. So I'm going to write 2k. So when 2k is divided into that number, into that value, I'm going to remain with what? K plus there, that is 3. So what is common there? That is negative 1. Open brackets, k plus 3 is equals to what? 0. So from there, same procedure, I should couple these two numbers, that is 2k minus 1, then k plus 3. Since these two are common, just get one bad, is equals to 0. So either 2k minus 1 is equals to 0, or k plus 3 is equals to 0. So make k the subject of the formula, that is 2k. This one become a positive 1 when it crosses the equal sign. So divide both sides by 2. So k equals to 1 over 2. And then also this side, when that positive 3 crosses the equal sign, to become a negative 3. So from there you have to recall what you related. So recall that e to the power x is equals to k. So from there, that is, you have calculated your k to be half, that is e of that is equals to 1 over 2. So from here what you're going to do is that introduce in to the both sides. So that is in e of that is equals to in 1 over 2. So this x is going to drop this side, so that is x, and then in that is 1, so that is 1 times x, which is x, so in 1 over 2. So this is one of our solution. So we see, let's also try to calculate for negative 3. So before we go to that of negative 3, other people, they can simplify this one to say in. So what is inside there is the same as writing like that, negative 1, and then they make this negative 1 to drop. So that is x is equals to negative in of what? Of 2. So you can end from here. So we also try to calculate for this one. So that is in of x, e to the power x is equals to k. So that is, so our value of k, that is negative 3, introduce in to the both side, that is in of x in negative 3. So that is x is equals to in over negative 3. So automatically this one is rejected, because when you try to punch on the calculator to bring mass error, so this one is rejected. So this one is accepted. So just try to punch on the calculator, you're going to see. So these are the possible solutions that were supposed to be there. We can proceed to the next question. So please, if you find this video interesting, don't forget to like this video, also subscribe. So question 3, they are saying if xy is equals to 64 and log base of xy plus log base of y, x is equals to 5 over 2. Find x and y. So we can answer. So we have been given x, y is equals to 64, and then we have also log base of x, y plus log base of y of x is equals to 5 over 2. So, and then they are telling us to find the values for what? X and y. So what you are going to do is that get the equation that is complicated. So we are going to start with this one. So if you look clearly you're going to see that the bases, they are not the same. But earlier I introduced a concept to say that if you are having log of a b, this one to change this b to become a base and this one to become a power, you have to introduce 1 over log b over a like that. So make sure you know this property of changing of bases. So that is log x y plus 1 over log x y is equals to what? 5 over 2. So from there I just to say let log x y is equals to n data of your choice, in this case that is k. So if I put k where there is log base x of y, it is going to be k plus 1 over k is equals to what? 5 over 2. So from there, over 1, the common denominator here, that is k. That into that, it's k times k square. K into k, it's 1. 1 times 1, it's 1. Is equals to 5 over 2. So what you are going to do, cross multiply. So that is 2. This 2 is being multiplied with the numerator, and that k will be that numerator that side. So that is k square plus 1 is equals to 5k. So 2k square plus 2 is equals to 5k. So from there, what you're going to do, you have seen that it has become now a quadratic. You just arrange it according to the quadratic expression, that is 2k square, this one is positive, become negative 5k plus 2 equals to 0. So from there, product sum factor. So product, like I said earlier, just get the coefficient of k square, multiply with the constant, that is 4. And then our sum, that is negative 5. What about factors? Numbers that when you multiply you get the product, and then when you add you get the sum. And that is negative 1, also negative what? Negative 4. So when you multiply these two numbers, negative to negative is positive 4. When you add, it's negative 5. So that is 2k square minus k minus 4k plus 2 is equals to 0. So from there you factor them out. It's more like you factorize. So what is common there, that is k remaining with the 2k minus 1. What is common, and that is a negative 2. So that into that you are getting positive 2k minus 1 is equals to 0. So the rule that couple these two, that is k minus 2, then 2k minus 1 is equals to 0. So from there, either k minus 2 is equals to 0, or 2k minus 1 is equals to 0. So from there, that is k is equals to positive 2, because when this negative 2 crosses the equal sign to become positive 2, and then that is 2k, that is 1 over 2 over 2. So k is equals to 1 over 2. Now you have to recall. So you have to recall. So recall that log of x of y is equals to k, and you have calculated your values to be. So the first one, that is log of x of y is equals to 2. So this one will shift that, so you are remaining with the y. So y is equals to x to power 2, and then the other one you have calculated the value of k to be half. So log of x y is equals to 1 over 2. This one is going to shift that one, so that is y is equals to x to power 1 over 2. So that simply means that you can simplify if you want. That is y is equals to this one can also be written like this one. So now from there, don't forget that in your question you are given to say x y is equals to 64. So make x the subject of the formula, so over y over y. So x is equals to what? 64 over y. So that simply means that in that equation where there is x, you are going to replace with this one. So that is y is equals to the square root of 64 over y. So from there you are having y is equals to square root of 64 over square root of y. So that simply means that over 1 there cross multiply, so square root of 64, that is 8. So that is y times square root of y is equals to 8. So from there, that is y times y to the power half is equals to 8. Now under rules of indices, if the bases are the same, so that simply means that you are adding the what? The power, that is 1 plus 1 over 2 is equals to 8. So 2 times 1, that is 2 plus 1, 3. So that is 3 over 2 is equals to 8. So what you are going to do is that multiply both sides by 2 over 3. 2 over 3. So this one will cancel. They're going to disappear. You're going to remain there with y is equals to. So that is cube root of 8 to power 2. So that is 2 to power 2. So the value of y, that is 4. So from there you can shift to the other one. Since you have known to say the value of y is 4, you can get that equation. So that is y is equals to x square. So 4 is equals to x square. So square root. So x is equals to what? 2. So these are the possible solutions. So please don't forget to share, like the videos. We are going to continue in part 2 of our revisions and the logarithm.